Evening folks, and welcome back to the WTF. And as promised, I have built up my LDMOS amplifier using the ART2K0, and I'm going to show you how we did that and what it looks like inside. Seems to work quite well actually. I don't think that I was ever going to get 2 kilowatts out of it as the device states. I think that's being a bit optimistic when you consider, you know, this is a multi-band amplifier and you have to think about it's obviously going to have a low pass filter, things like that. I think building a multi-band amplifier is a bit of a challenge, but I think I'm reasonably satisfied with the results. So it is more or less as I explained in the previous video. We've got an LDMOS amplifier here. I think I've managed to get about 1 kilowatt out of it. I'll give you a quick demonstration. Covers from 1.8 to 30 megahertz, so the whole of the HF band pretty well. Yeah, I would say all of it. And we've got complete monitoring. We've got an Arduino based control unit or protection unit, and also display, meters, band switching. It's water cooled. We've got another water cooled system here which works reasonably well. So what we'll do, I'm going to take the lid off it and show you inside, so show you what I've done, and we'll give you a quick demo of the amplifier. We'll connect it up to a dummy load and use the old Ellicraft K3 to put some drive into it and see what we get out. Right, here's the front. Let's just turn it on. I'll see if we can just zoom in on the Arduino display. I hope you can see that. So this is a LCD display which is linked up to my Arduino control module, and I have to say that I know squat all about computer coding. I used, for those who are interested, if you want to program an Arduino Nano or whatever, use Platform IO. Don't use the Arduino IDE because it's not particularly good, and you use AI, artificial intelligence. Platform IO has a artificial intelligence assistant. I think I use Cloud Sonnet, but you can use ChatGTP. You just ask it what you want and then it does the code, and then if there's any errors or things, it corrects it, and away you go. So what we've got here is we've got this toggle switch which sort of displays various parameters. The power on this, the power display doesn't really work terribly well because it's not accurate, so I've more or less ignored it, but it does. The SWR protection circuitry does work reasonably well. So you got SWR power, the voltage, amps, and basically those are the board voltage, which is 12 volts, and then we've got the main voltage on this, which is 53. Seems to have gone out of focus slightly. And then if I toggle it again, we've got efficiency or power in, which is amps times volts obviously, and the efficiency, which unfortunately I can't measure because the power output measurement is not particularly accurate. So again, unfortunately we have to ignore that one. And then most importantly, we've got the temperature of the heatsink. So here we've got the band switching for the low pass filter. Just zoom out a little bit. So that's there. You just simply turn it there. We've got our transmit switch, which is this one here, and this controls the water cooling. Again, the water cooling is controlled by the Arduino, so at a certain temperature, I think it's 35 degrees, the water cooling will come on automatically, but you've got the option of turning it on and off. So there we go. That's the front panel. Then we've got some nice analog meters there as well, displaying the current and the voltage of the supply. And those They actually look quite vintage, but they came from AliExpress. They weren't particularly expensive, so good source for sort of vintage looking meters. I've actually just turned the water cooling thing off because the lights from it, which may not be to everybody's taste, but I think I think it looks quite Gucci, if nothing else. Yeah, I've turned it off because of the camera, so it's may not be to everybody's taste. I may do something with that at a later stage. Anyhow, let's have a look. We've got the power supply there. That's a flat pack 3 kilowatt server power supply, which supplies 54 volts at 50 amps if necessary. Those are our changeover relays. A coaxial one. It's rated at 1 kilowatt, that one actually. And then that's a water supply, cooling supply as mentioned. We've got a dual directional coupler, and this particular board, I was going to make one up myself. I did have some left over from my MRF 300 project, but in the end I decided I would just get one of these from VK Amps. And the main reason for this is because these are, well, these come with AD8307 logarithmic amplifiers on the output, and I thought maybe those would be useful for displaying the power. Turns out that at about 100 watts they get saturated, and then if you try to attenuate the signal then you lose your SWR, and it was just a bit of a nightmare with the coding for the Arduino. So there's the that there is the low pass filter board, and the board itself came from W6PQL. It's a W6PQL board, and I've just put in the relays and the coils in. The capacitors actually are big ATC capacitors, which I showed you on the previous video, those really juicy ones, big ceramic ones, which are rated to about 2.5 kV. So this is the actual board, the RF pallet, and again the boards are from W6PQL, and the LDMOS is underneath that copper clamp, I would probably the best way to describe it. And I haven't soldered this. This is screwed onto the copper heat spreader, and I'm using liquid metal compound, which I think it may be slightly better than solder because it's a thinner layer, and I think it's probably got better conductive powers. And it's the sort of stuff that you use for PCs, overclocking PC microprocessors, and I used it before on the MRF 300. It does seem to work quite well. Those cores there are type 61, and we've got a 4:1 output transformer followed by another 4:1, so a total of 16:1 for the ART 2K0, and seems to work okay. And that big humongous common mode choke or balun is there on the output. The controller that's the Arduino controller in that die-cast box, just to shield it from the RF. And I do, rather than take that lid off, I should have a picture to show you what it looks like on the bench, and so you give an idea of what I've done there. Just a couple of relays, the Arduino, which I've programmed on Platform IO on Visual Studio Code, and that's about it. So what we'll do is we will connect it all up and give you a quick demo, see how many watts we can get out of it. So at the moment, it's worth looking at the temperature gauge there. We're at 22 degrees centigrade. We've got 54 volts there, no current at the moment. So we'll switch the amplifier on and we'll see how much power we get out. At the moment I'm running about 55 watts through a 13 dB attenuator, so that gives you an idea of how much power we're actually putting in. Pull over my Morse code key. So it's about 800 watts. the temperature goes up to 32 degrees. That's on the heat sink. Just come away a little bit. So that gives you more or less idea. On the other bands, 40 meters is slightly about 100 watts less, and it sort of goes down. But it gives a reasonable output power, you know, for a usable amplifier for HF. I'm a bit wary of overdriving this. I mean, it's 55 watts in for a 13 dB attenuator. You could probably increase a little bit, but I'm very wary about blowing up the LDMOS, the ALT2K0, because they are £250 a pop. So I'd rather just treat it with a bit of respect and not go too mad trying to overdrive it and blow the thing up. Unlike my very large GU81 amplifier, which can take a lot of abuse. That's one thing about valve amplifiers compared to solid state. So there we are, folks. That is the completed ART2K0 LD amplifier. So in operation as a bench amplifier, useful for full legal limit power, and I'm quite pleased with the result. Keep watching and see you again next time.